Alright, hello. In this video we're going to be working on finding the focus and directrix of a parabola. We're going to be working through Algebra 2 Homework 4.3. Okay, so we're going to sketch the parabola and then write the equation in vertex form and in standard form. Okay, so we're given focus and directrix. So focus point is here, 0, 3. And then the directrix is below where y is -5. So we know the vertex will be halfway in between, right? So it'll be halfway between 3 and -5, and we can find that by, averaging them, adding them together, and dividing by 2. So that'll be at 0 and -1. Okay, and I know it'll open up because the parabola curves around the focus. Okay, that was not very symmetric, but yeah, it's good enough. That's a sketch. Okay, we know that P, which is the distance from the vertex to the directrix, or the vertex to the focus, it's going to be 4, okay, because it's from -5 to -1. Okay, so I've got P equals 4. And we know that vertex form is y equals some number, we used to call it a, but now we're calling it 1 over 4p. Times x minus h squared plus k, where h and k are the coordinates of the vertex. Okay, so I've got everything I need. I'm going to say y equals 1 over 4 times 4 is 16, times x minus 0 squared plus k is -1. Okay, that's a vertex form equation. If I wanted to make this standard form, I would, actually square this, but this won't be too hard. 1/16 of x squared minus 1. Okay, that's vertex form, that's standard form. Right, number 2, same thing. Okay, we've got a focus point right here, 0 and -2. Okay, the directrix is y equals +8, which is going to be up above this point because the y coordinate's greater. Okay, so I know that the vertex is going to be halfway in the middle, and then it's going to curve down like that. Okay. Halfway in between -2 and +8 would be okay. I'd add them together and get 6 and divide by 2, and I'd get 3. Okay, the x coordinate's still going to be 0 because I'm just like above. I haven't changed to x. I'm going straight up and down. Okay, so I've got the vertex. I'm going to need the distance from the vertex to the focus, or the vertex to the directrix. That's looking like 5. Right? 5 from -2 to 3, and 5 from 3 to 8. Okay, so I've got p equals 5. Now I'm going to say, all right, y equals 1 over 4p times x minus the x coordinate of the vertex squared plus the y coordinate of the vertex. Okay, that's vertex form. And then standard form would be 1/20th of x squared plus 3. Okay, which, for these couple ones where the vertex was on the y-axis, it doesn't really look that interesting. But that is vertex standard form. Now here we've got something a little more interesting. All right, vertex at 5 and 2, and focus at 5 and 17/8. Okay. 2, that would be 16 divided by 8, right? So I know that the focus is going to be 1/8 above the vertex. And we know, it doesn't have to be, you don't have to make it, super close, right? It's just a blank white field. You can draw this however you want. 5 and 17 over 8. And then the focus right here, so, no, that was the focus, and then this is the vertex. That was 5 and 2, which I might call 16 over 8. Okay. And, okay, might as well directrix as well. The directrix is going to be y equals 16 over 8 minus 1 over 8, because I go down 1/8, so it would be 15/8. Okay, and I know it didn't ask for the equation of the directrix, but I'm just going to show you how you would find it, just in case there aren't any of that type of problem on this set. All right, so I've got all this, and so it's looking like the value of p is equal to positive 1/8. Okay. And so my vertex form equation is y is equal to, okay, 1 over 4p. I might just kind of start with this. 4p is 4 times 1/8 is 1/2 times x minus, what am I thinking here? The x coordinate of the vertex, it's 5, plus the squared plus the y coordinate of the vertex, which is going to be 2. Okay. Now we could probably do a little bit more with that. 1 over 1/2, that's like, dividing by 1/2 is like multiplying by 2, so I'm going to call that 2 of x minus 5 squared plus 2. If I wanted to write this in standard form, then I'm going to have to actually, expand x minus 5 times x minus 5. Okay, so I might do this off to the side. Okay. So I'm going to add all of these together, and that would be x squared minus 10x plus 25. But then I'm going to have to double it. So it's going to be 2x squared negative 20x and positive 50, and then plus 2. Okay, so my standard form is going to be y equals 2x squared minus 20x plus 50 plus 2 is going to be plus 52. Right, another one of focus vertex. Okay, so we've got ourselves here. Okay, vertex at x equals negative 2 and y is positive 0.25. A focus point at negative 2 and negative 1/4. Okay, so that means that the distance from the focus to the vertex, and that's going to be the value of p, is 1/4 minus negative 1/4, top minus bottom, is going to be 1/2. And then, because we know that, okay, this is the vertex point and this is the focus, we know that the parabola curves around the focus. And then the directrix is going to be another half above the vertex, and so I might as well draw that in as well. And that directrix is going to be y equals 1/4 plus 1/2 is 3/4. So that's the equation of the directrix. All right, now if I want to put in the vertex form, I'm going to say y equals 1 over 4p. So 4 times 1/2 is 2, multiplied by x minus the x coordinate of the vertex, squared plus the y coordinate of the vertex. Okay. And now I'm going to have to expand x plus 2 squared in order to write this in standard form. So I'll take the x plus 2 and multiply it by the x and the plus 2. And got x squared, 4x, and 4. Okay, yeah. And so I'm going to need to multiply 1/2 by this whole thing. Okay, so when I do that, so that will be my vertex form equation. And my standard form equation, yeah, you can see that. Now that's going to be, okay, take this and multiply it by 1/2 because this is x plus 2 squared. So 1/2 x squared. Let's see, I need a y equals there, don't I? So I've got 1/2 x squared plus 2x. Okay, and I would have 2, but now I'm going to add a quarter, so it would be, you could write 2.25, or we could say 2 is 8/4 plus 1 more fourth. It's going to be 9/4. Okay, and that's a standard form equation. All right. Now we've got vertex and directrix, but no focus. Okay, I'll show you how to find the focus from that. Okay, vertex at x equals -9 and y equals 4. Okay, and then the directrix is y equals 0. Well, y equals 0 is going to be below y equals 4, so I'm just going to... Okay, that's going to be the x-axis. We know the x-axis is the set of all points where y equals 0. Okay, but if this is the vertex here, then the focus is going to be another, this distance above. So if I went from 0 to 4, that gives me a p equals 4. That's also going to be 4. And so that would be -9 and 8 is the focus. Oh, God. This was great. No, it was not. It's okay, though. And, all right. I've got the distance from the vertex to the directrix. I've got the coordinates of the vertex. I'm ready to write my equation. Okay. So my vertex form equation is going to be y equals 1 over 4p, okay, well, p is 4, that'll be 1 over 16, times x minus the x coordinate of the vertex squared plus the y coordinate of the vertex. Maybe this time I'll go over here. If I want to do x plus 9 squared, I'm going to do x plus 9 multiplied by x plus 9. Okay. And I'll have x squared plus 18x plus 81. Okay, but I'm going to divide everything by 16. Okay, so and then my standard form equation is going to be y equals, okay, I got to multiply this whole thing by 1/16. So 1/16 of x squared plus 18/16 x plus 81 over 16 plus 4. All right, if we needed to clean this up, which I don't know if we do, but suppose it was multiple choice and it just had a fraction as the the last number, we would need to clean this up. So 4 is something over 16. Okay, 16 times 4 is 64. I know that. So I think this is going to be 64 over 16. Yeah. Okay. So that would be 145 over 16. And that's probably not simplified either, but actually, yeah, it actually is, I think. Plus 18 over 16x plus 145 divided by 16. Yeah, if 16 had a, oh no, not even, I'm not sure about 145. I thought it was divisible by 3, but not. So, okay, that's going to be my standard form equation. Now, if I've got this vertex and that directrix, I'm going to just plot the vertex. And then, okay, -1. So this is -3, -1. And the directrix is y equals -11/12, which is not quite all the way to -1. Okay, so it's going to be above. I'm going to just draw that directrix here. And then I'm going to say, all right, well, I know that the parabola goes away from the directrix. And, okay, this distance here, it'll be the same distance over here to the focus point. Okay, and this distance here, that was, went down by 1/12. Okay, so I'm going to say P equals 1/12. And P equals 1/12 there. And, okay, since I've got the coordinates of the vertex, oh, what I was going to say is if I wanted to write the coordinates of the focus, this would be x is still -3, but y is more negative than -1 by a 12th, so -1 minus a 12th would be -13 over 12. Just going to point that out. And then, okay, yeah, I'll write a vertex form equation. That'll be y equals 1 over 4p multiplied by x minus the x coordinate squared plus the y coordinate of the vertex. Okay, so 4/12, that's 1/3. 1 divided by 1/3 is going to be like multiplying by 3, so I'll have 3 times x plus 3 squared minus 1. Okay, and then if I want to write this in standard form, I'm going to need to square x plus 3. Okay, so it's going to be x squared, 6x, and 9. All right. And, okay, yeah, if I'm multiplying this by 3, then I have to distribute the 3 to everything. So I'll have my standard form equation, right? 3x squared plus 18x plus 27 minus 1 is plus 26. And that's a good standard form equation. Okay, now we're going to sketch the graph while giving the coordinates of focus, equation of directrix, and the coordinates of the vertex. Okay, so we're starting off with a vertex form equation, and we're going to do all those things. Okay, so I think the first thing to do is to find the vertex, even though it says do it last. I'm going to say, all right, the vertex is going to be where x is equal to 1, whatever makes this thing 0, and then whatever's the y coordinate that corresponds to x equals 1, well, that's just going to be 0. Or it's the number that's added on the outside, but that's more of like a symptom than the cause. And, okay, so this is the vertex, and then it's going to open up, and I'm going to say, all right, because 1 over 8 equals 1 over 4p, that's going to give me p equals 2. Okay, so I know that it's going to be a distance of 2 from the vertex to the focus and from the vertex back to the directrix. Okay, so I'm going to okay, parabola. I know it opens up because of the positive 1/8, and I'm not even worried about, I mean, I know that positive 1/8 x squared is going to be super wide. I don't care that much because it's just a sketch. And so this is x is 1 and y is 0, so it's on the x-axis. And I know I'm going to go up by 2 to get the focus, and I'm going to go down by 2 to get the directrix. Okay, so the focus point here, and then I guess the directrix would be there. The focus is going to be where x is 1 and y is 2. Because I go from y equals 0 up by 2 to y equals 2. And then the directrix is going to be 2 below y equals 0. And okay, that's focus and directrix. I wrote down the vertex. Yeah, we did that. Okay, let's move on. So the vertex here. Okay, that's going to be where x is -2, because this is x minus -2. And y is going to be -3. Okay, I know that this parabola is going to open down because of the -1/2. So I'm going to just kind of draw in the vertex there. And draw a downward facing parabola. Okay. And what was that? Oh, okay, so I've got the vertex here. I need to figure out the distance from the vertex to the focus and everything. Okay, so I've got 1 over 2. I mean, you can keep the -1/2 and note that because it's negative, you would go down for the focus if that's how you're going to remember. I think it's better to just think that the focus is on the inside of the parabola, and because it opens down, it's going to be down to get to the focus. So I'm just going to take the number here and say that's 1 over 4p. Okay, I'm looking at this and I'm saying, okay, p needs to be 1/2. because I need to, reduce this to get this down to 1 over 2. Okay, so I've got p equals 1/2. So I can go up 0.5 to get to the directrix, or I can go down 0.5 to get to the focus point. So if the vertex is -2, -3, I go down by 1 to get the focus point. Now I'll have x equals -2 and y equals -3.5. And then the directrix, okay, that's going to be up by 0.5 from y equals -3. So that would be y equals -2.5. And it's the set of all points on this line. So it's the set of all points that have y equals -2.5. Okay. All right, number 9, y equals x squared minus 6x plus 8. This is when we're going to have to complete the square to write this in vertex form and then do what we just did, right? So I'm going to do some complete the square work over here in blue. So I need to think about what number do I need to add to both sides of this equation to take x squared minus 6x and turn it into a perfect square. So I'm just like adding in a space for me to add the same number to both sides of this equation. And what I do is I'm going to take the -6, I'm going to divide it in half, and then I'm going to square it. So I'm going to say -6 over 2 squared. Well, that's -3 times -3 is going to be +9. So I'm adding 9 to both sides of this equation. And I'm going to factor this. Okay, this is going to be x minus 3 times x minus 3. And then I'm going to solve for y by subtracting 9. Minus 1. All right, so I've got everything I need. Got it in vertex form. I'm going to say that this is going to be at x equals 3 and y equals -1. So right there. I know it's y equals +1 x squared, so it's going to open up, and the focus point will be above the vertex. And what was I thinking about this one? Okay, so I need to find the distance from the vertex up to the focus. Okay, so this is just a 1 right here. Okay, so 1 equals 1 over 4p. And we know that 1 is 1 over 1, so that means that p is going to need to be 1/4. Or you could say 4p equals 1 if you cross multiply it, or multiply those sides by 4p. Doesn't really matter. You're going to get p equals 1/4 if you do it right. So that means that I need to go up by 1/4. And then also down by 1/4, and that will give me my focus point and my directrix line. There we go. All right, so the focus point is going to be, right, x will still be +3, y will be greater than -1 by 1/4. That's going to be -3/4. And then the directrix, thinking, okay, it's going to be below y equals -1 by 1/4. You could say y equals -1.25, or you could say y equals -5/4. Either way, doesn't matter. But that's all for that one. Number 10 is y equals -3x squared minus 3x plus 6. Okay, good. I was hoping that there would be one where we had to complete the square, but where the leading coefficient wasn't 1. When that happens, we factor out the -3 from the x squared and the x. And we're going to leave room to add the same number on both sides. And I'm factoring out the -3. Okay, so not only was it one of those, but it was one where when we actually complete the square, it's going to be really annoying because it's an odd number here. Okay, that's fine. We can deal with that. +6. Yeah, totally. We can do this. Okay, so I have to figure out what am I going to add to both sides of this equation to, to complete the square, to make the thing in square brackets a perfect square trinomial. So I'm going to go over here and I'm going to take the number attached to the x after the factoring. It's going to be positive 1, dividing it in half and then squaring it. And that's 1/4. So I'm going to add 1/4 right here. Now on the other side, I'm not going to just add 1/4 because that would not be fair to both sides. If I think about what I've added here, I've added -3 times 1/4. So I need to subtract 3/4 because I subtracted 3/4 over here. And then, what was I thinking? Ready to factor. Okay, it'll be x plus 1/2 squared plus 6. Okay, so I'm going to add 3/4. Okay, 6 is 24/4, so I'd have 27/4. Okay, and then I've got myself a vertex form equation. I've got a vertex. I didn't really clearly label it in the previous problem, but it's going to be all right. X equals -1/2 and y equals 27/4. Hold on, I'm thinking about this. Oh, it'll be all right. The numbers on this one are going to continue to get worse, but it's not a big deal. Okay, this is going to open down and be very narrow, so I'm going to let it open down, and then, okay, I've labeled the vertex. The directrix will be up here above. The focus will be the same distance below. And now I just have to figure out what is the value of p. How far am I going in each direction? All right, so 3, run myself out of room. It's all right though. So a is 3 or -3, however you want to look at it. And we know that a is 1/4p, and you can't even see that. Yeah, a is 1/4p. In this case, I might recommend, cross multiplying. So I'm going to multiply here. That'll be 12p equals 1 times 1. And then I could divide by 12 and get p is 1/12. All right, so that's going up by a 12th and down by 1/12. Okay, so directrix, I'm going to have to subtract a 12th, which I don't want to. I could. 81. Yeah. Sure. Okay. So I'm going to think of this as 81/12 because 27 times 3 is 81. And, okay, so for the directrix, it's going to be y equals 27/4 plus a 12th. Well, this is 81/12 plus 1/12 is 82/12. And, we could definitely reduce this to 41/6, but, I'm just not going to. And then the focus point is going to be, okay, x will still be a half because it's just right below it. And y is going to be 27/4 is 81/12 minus a 12th is 80/12. And you could reduce that. I mean, you could make that 20/3 maybe, but you could also not, and that would be fine. That was a pretty intense example. Good talk. All right. The graph of a parabola and its directrix are shown. Write an equation for the parabola in standard form. I like that. Looking at a picture of the graph. I like that. Multiple representations. Okay, so we've got a vertex here, which looks like it's at the point x equals 2 and y equals -6. Okay, I'm just going to make note of that over here. Okay. The distance from the vertex to the directrix is looking like, okay, that's y equals -3, I've got to assume. That's going to be a distance of 3. And it opens down. Okay, so I've got vertex, directrix, y equals -3. Okay, so that means that, I know it didn't ask for it, but the focus point is going to be where x is 2 and y is -6 minus 3 is -9. really need is p equals 3. Okay, in standard form. Okay, so we're going to start with vertex form, and then we're going to expand it like we did on those other problems. Okay, so vertex form is y equals 1 over 4p times x minus the x coordinate of the vertex squared plus the y coordinate of the vertex. Okay, if we want to expand this so as to actually write it in standard form, I'm going to use the box technique. Okay. Oh yeah, I've been actually writing out what it equals. X squared minus 4x plus 4 right there. And then over here, I'm going to, what am I going to do? Oh yeah, divide all of this by 12. Okay, so y equals 1/12 of x squared minus 4/12 of x plus 4/12 minus 9. Okay, and so yeah, I'm going to just kind of start combining some things. 1/12 of x squared minus 1/3 of x. Okay, 9 times 12 is 108. So if I have negative 108 over 12, and I add 4 over 12, I'll have negative 104 over 12. Okay, and again, you could simplify this into 52 over 6 equals 26 over 3. But, no sense in it. Right, over here. Right, this looks like a graph I made myself. Okay, so the vertex is at x equals -1, y equals 2. Okay, the directrix. And kind of lost track. Oh yeah, the p-value. Okay, so the distance from the vertex to the directrix looks like it's 0.25. So if I went up another 0.25, I'd have the focus point. And maybe that's why you see why I drew those images a little exaggerated on the sketches on the previous problems. Because if you draw it accurately, it's just like, oftentimes they're really close together. And, okay, so I've got all of this. This is great. Focus point is going to be x equals -1 and y is equal to 2.25. Okay, so if I want to write a standard form equation, I got to start with a vertex form equation. So that's y equals 1 over 4p, well, 4 times 0.25 is 1v1, times x minus the x coordinate of the vertex squared, plus the y coordinate of the vertex. Okay, and then what am I going to do? I was thinking about my calculus class, and there's not a thing to be doing while I'm working algebra problems. Oh yeah, I need to square x plus 1. Yeah. Okay, so I'll use the box technique. Okay, so it's going to be x squared, 2x, and 1. And, luckily I won't have to multiply it by anything, so I'm just going to have x squared plus 2x plus 1 plus 2 is going to be 3. So, and that makes sense. We've got a y-intercept of 3 right there. Okay, that's a good sign. Y equals x squared plus 2x plus 3. That was good. What else we got? Oh, we've got a marked focus. Oh, I remember making these graphs. Yeah, these are not the best graphs ever, but it's okay. Made with Microsoft Paint. So we're going to write an equation for the parabola in standard form again. So I need to find the vertex. That's x equals 2, y equals 1. Okay, the focus point appears to be x equals 2 and y equals 7/8. So I think that the distance from the focus to the vertex is 1/8. And, oh yeah, this is interesting. It doesn't look like it because it's so zoomed in, but yes, it's gonna... Okay, we'll see how that goes. Focus, the directrix is going to be back 1/8 above here. So that would be 1 plus 1/8 is 9/8. Okay, so I'm going to write that in. Y equals 9/8. So I've got all the ingredients I need. I'm going to start with vertex form. Y equals 1 over 4p. 4 times 1/8 is 4/8. Times x minus the x coordinate squared plus the y coordinate. Okay, well, 1 over 4/8 is divided by 4. So y equals 2 times x minus 2 squared plus 1. You know, maybe I need to find out what x minus 2 squared is. So I go here. Okay, that'll be x squared minus 4x plus 4. Okay, but then if I'm doubling that, I need to double everything. So y equals 2x squared minus 8x plus 8 plus 1 is going to be plus 9. That's not a good sign. What have I done? I needed to multiply this by -2 because this is opening down. Okay, I caught that because I was like, oh, this is definitely not having a y-intercept of positive 9. Okay, so I am going to need to clear some stuff out. All right, so what's going to change this result? I think that would become a -2 here. So this would become a -2x squared plus 8x minus 8 plus 1 is going to be -7. Okay, -2x squared plus 8x minus 7, that looks like something that could happen. It could have a y-intercept of -7 down there that's, you know, out of sight. All right, now here we've got one more, and all right, 3 and 1.25, and the focus is at 3 and 2. Oh, that's nice to do one where the vertex is at the non-integer. Okay, I can work with this. I'm thinking... Okay, first, and the vertex is already labeled for us. So I'll figure out, you know, what's this distance from the vertex to the focus. 1.25 to 2 is 3/4, equaling p. Right, and then the vertex, I'll just label it there. Okay, so if I went up by 3/4, I would need to go down by 3/4 to get the directrix. And so I'd say 1.25 minus 3/4 is going to be a half. So y equals 1 over 2. And then, all right, my vertex form equation is going to be y equals 1 over 4 times 3/4 of x minus the x coordinate of the vertex squared plus the y coordinate of the vertex. So, all right, if I multiply these, okay, 4 over 1 times 3 over 4 is 3. So y equals 1/3 of x plus 3 squared plus 5/4. So I'm going to use a fraction because I can see that when I multiply by 1/3. Yeah, we'll see. We'll see how it goes. I might go back to decimal at the end. But at this point, what I need to do is I need to square x plus 3. I've already done that once in this video. So if you're not sure why, go back and look at. I thought I had. Square. Yeah. Number 6. Go look at number 6, and you'll see why this is x squared plus 6x plus 9. So 1/3 of x plus 3 squared is 1/3 of x squared plus 2x plus 3. Okay, yeah, when I add 3 plus 1.25, I'm going to call that 4.25. Forget the 5/4. Okay, but my standard form equation is 1/3 of x squared plus 2x plus 4.25. Okay, and that's number 14. Yeah, that's all the problems that we've got for this problem set. Yeah, that's all.